Okay, so if we look through all the past induction questions that have been asked in the past, so we can see it's something that comes up every couple of years. If you're really looking to get good practice at these, you can go to the questions pre-2013. They get more difficult as they go back. There's a lot of interesting questions in there. But the one that we want to have a look at is the one that's specifically in this syllabus. So this question here, prove by induction that 1 plus x to the power of n is greater than or equal to 1 plus nx, for x greater than minus 1 and n a natural number, that's specifically mentioned in the syllabus. So it hasn't come up yet, and so it's something that's worth having a look at. Let us start by writing down our headings. So we want to show that this is true for n equals 1. So we have a look at our conditions here. N has to be a natural number. The smallest natural number is 1. So we're going to show true for n equals 1. So let's go and do that. So we're going to sub in 1 for n. So we're saying that 1 plus x to the power of 1 is greater than or equal to 1 plus 1 times x. So 1 plus x is greater than or equal to 1 plus x, which is true. 1 plus x is equal to 1 plus x. So the condition was that it's greater than or equal to, it is equal to. So the second step then is we're going to assume it's true. Assume true for n equals k, and that just means taking our inequality and replacing the n's with a k. So 1 plus x to the power of k is greater than or equal to 1 plus kx. And we leave that, we'll return to that in a second. We then want to prove true for n equals k plus 1. So that's 1 plus x to the power of not k, but k plus 1 is greater than or equal to 1 plus, instead of k, we have k plus 1 times x. Now, we can leave this or we can tidy it up. I'm going to tidy it up a little bit. I might multiply out the right hand side. So 1 plus x to the power of k plus 1 is greater than or equal to 1 plus k by x is kx, and 1 by x is 1x. Now, at this point, I like saying that I'm going to call this A and this is C. What we're trying to prove is that A is bigger than or greater than or equal to C. We return to the assumption, which is here, and we're going to write down what we assume is true, which is 1 plus x to the power of k is greater than or equal to 1 plus kx. I need to turn the left hand side of this into this A down here, 1 plus x to the power of k plus 1, and the way that I'm going to do that is I'm going to multiply both sides by 1 plus x. 1 plus x to the power of 1 times 1 plus x to the power of k. So I'm going to multiply the right hand side by 1 plus x to the power of 1 as well, which is just 1 plus x, but we're just putting in the 1 so we can see what happens here on the left, on 1 plus kx. I'm going to tidy up the left hand side using the rule of indices that we add the exponents when we have the same base. So that's 1 plus x to the power of k plus 1 is greater than or equal to, and I'm going to multiply this out. I'm going to say 1 by 1 is 1, 1 by kx is kx, x by 1 is x, and x by kx is kx squared. Now, what I have here is that A, that's the same as the A down here, and what I'm trying to prove is greater than or equal to something, let's call the something B. The idea with inequalities is that I'm trying to show that A is bigger than C. I know now that A is bigger than B. If I can prove that B is greater than or equal to C, well then A is going to be greater than or equal to C. So B is 1 plus kx plus x plus kx squared, greater than or equal to C is 1 plus kx plus x. I'm going to subtract 1 from both sides, I'm going to subtract an x from both sides, I'm going to subtract a kx from both sides, and I'm left with kx squared is greater than or equal to 0. Now, if kx squared is greater than or equal to 0, then B is bigger than C, and if B is bigger than C, A is bigger than C. How do I know that kx squared is greater than or equal to 0? Well, x squared is going to be a positive number, or it could be the number 0, so on 0 is equal to 0. So it's positive or 0 because x is a number that's greater than -1. We square a negative number. Even if we squared -1, we get a positive number. And k is a natural number. So the condition in the question is that we're only going to sub numbers that are natural numbers in for this to be true. This is only true for natural numbers. Well, so k would be a natural number in that case. A natural number is positive. And so if we multiply a positive number by a positive number, that's greater than or equal to 0. And if we multiply a positive number by 0, that's equal to 0. So whatever way we look at it, given the conditions in the question, n or k being a natural number and x being greater than -1, b will be bigger than c. If b is bigger than c, we know that a is bigger than b. That means that a is bigger than c. And the way we might write it at the end is that a, 1 plus x to the power of k plus 1, is greater than or equal to what I'm calling b, which is 1 plus kx plus x plus kx squared. And in turn, that's greater than or equal to c, which is 1 plus kx plus x. So we have to finish off with a statement. So our statement then is, we have shown it's true. We have shown the proposition is true for n equals 1. If the proposition is true for n equals k, then it is true. Then it is true for n equals k plus 1, and therefore true for all n natural numbers. Okay, a lot of people get caught up in the x in this question, and this could be asked possibly where x is a number. They tell us that x is a number greater than -1. If this question was done in the form 1 plus, and we're just going to make up a number. So let's say that x is 7. 1 plus 7 to the power of n is greater than or equal to 1 plus, again putting in 7 for x, 7n. We would want to show that this is true. Like x just stands for some number. A lot of people get caught up with the x in this question, but it's an unknown number in the question. And no matter what we subbed in for that x, once it's bigger than -1, this proposition holds true.